Okay, so this is our unit circle 4 parts worksheet, and here are some of the key things. We've already done this one here, so I'm not going to spend too much time on it, but this point was, these are 90-degree marks. So this is 0 degrees, this is 90 degrees, this is 180 degrees, and 270. Okay, and then we go ahead and have our points. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So this is an important piece of the unit circle, and we've got those. Okay, so I'm going to go ahead and zoom in and over. Now we're going to deal with 45-degree increments. And notice here when we're finding trig values around a circle, we have, excuse me, we have the reference angle that we're going to use. And if you notice here, the way that this drawing is set up, we did a video where it was like 60 degrees was a reference angle all the way around. All these guys are 45 degrees. And what we found out in that problem is that, hey, all these guys are going to have the same value, but there's just positive or negatives, right? Because we're on a quadrant. I mean, a circle is going to have some of the same values, because if we look at this guy right here, well, they have the same height, right? So their y value should be the same. These guys have the same height, so their y value should be the same. And it looks like their distances along x, like if I drew a vertical line straight up and down, it would probably be a straight line, right? It would intersect the x-axis at 90 degrees. So the x and y's are the same distances. We're just moving up and down or left and right. Okay, so on the right side of here, I'm going to go ahead and I'm going to draw a 45, 45, 90 triangle. And we're dealing with the unit circle. So this is technically 1, right? I do this a little bit of a different way, but I want to make sure we understand that this is 1, and I'm going to draw a triangle to find out where this coordinate is. And so we've talked about, okay, well, this is x root 2, this is x, and this is x. So if x root 2 is equal to 1, x is equal to 1 over root 2. And if I rationalize, that's the same as root 2 over 2. So what I do sometimes is I cheat, and knowing that that's going to happen, I just use my traditional 45, 45, 45, 45 settings, and I get, okay, well, what's sine of this triangle? Well, sine of this triangle would be 1 over root 2. Notice we're getting the same thing. So whether I call the radius root 2 or whether I call the radius 1, we're going to get the same value. It's a unit circle, so technically the value is 1. So because we're dealing with a unit circle, we know that sine is equal to y. So I know, so just for discussion's sake, this is a unit circle. So technically, and I'm looking at this side, if I find sine, it's opposite over hypotenuse. So what that means is when we rationalize, this side is going to end up being root 2 over 2. And this side is also going to be root 2 over 2. So this point, my x distance is root 2 over 2, comma, root 2 over 2. I can do the same thing on this side. Okay, well, if this is a 45, 45, 90, well, aren't all these values going to be the same? So I would do the same thing, but I would get root 2 over 2 for this guy, but this one's a negative root 2 over 2. So what that means is, hey, okay, well, I moved a negative root 2 over 2 this way, and I moved up a root 2 over 2. And for all these guys, we're doing radical values only, no decimals, no rounding. And so we're going to follow that same logic all the way around the circle. Let's see if that one erased, sorry about that. So 30 degrees, and what we have here is we got a couple different marks for 30s. So this technically right here, this line right here is a 60 degree, which we're going to do next. So I'm just going to focus on the ones right here. So we're going to draw a triangle, right? So let's do this one, and I hope we're seeing the pattern that once I find one of the triangles, right? These are all the different triangles, makes a nice little bow tie here. Once I find one of the triangles, I can go ahead and find everything else just by using the ideas of symmetries and reflections is technically what it is, but putting a negative where it belongs. And so I'm going to put my 30, 60, 90 in perspective of this guy right here. And I'm actually going to use the 2, the 1, and the root 3. Even though it's a unit circle, and technically this guy should be 1, it doesn't matter. When I divide it out and set it up, I'm going to go ahead and get the appropriate values. So sine of 30 degrees is equal to opposite over hypotenuse, right? This is going to end up being 1/2. The other one, which is cosine, which is our x value, right, is adjacent over hypotenuse. And that's going to end up being root 3 over 2. And think about it. If we considered this to be 2, technically this should be 1, right? But what happens when we go ahead and do the division and simplify out the whole trig value, it actually changes it back to the radius of the unit circle, giving us 1, so it works out nicely. So this point right here is going to be root 3 over 2, 1/2. So then this one is going to be negative root 3 over 2, 1/2. And this guy is going to be negative root 3 over 2, negative 1/2, and so on. Okay? That would be a positive. And these are how we can find all the different values on the unit circle. Why don't you guys go ahead and try the last one on your own, pause the video, and then the answers will be plopped up there when you start the video again. Okay, so I went ahead and I put a box around it just to make sure. So first quadrant, both are positive. Second quadrant, negative, positive. Third quadrant, negative and negative. And fourth quadrant, positive and negative. And notice here, this guy right here should be a negative value. I noticed that. So, and that's how we can find all the values. And in my next video, I'm going to show you a quick trick of finding the unit circle values and kind of memorizing them.